4.25. A circular coil of 20 turns at radius 10 centimeter is placed in a uniform magnetic field of 0.1 Tesla normal to the plane of the coil. If the current in the coil is 5 ampere, what is the total torque on the coil? B. Total force on the coil. C. Average force on each electron in the coil due to the magnetic field. The coil is made of copper wire of cross-sectional area 10 raised to minus 5 meters square, and the free electron density in the copper is given to be about 10 raised to 29 per meter cube. Now see, total number of turns given to you in the coil, that is 20, radius of the coil, that is 10 centimeter. So that is 0.1 meter. B, that is 0.1 Tesla. Current through the coil, that is 5 ampere. Now see here. It is placed in the uniform magnetic field normal to the plane of the coil. Field is normal to the plane of the coil. So this is the plane of the coil and normal to it. So field is like this. So if we take the area vector for the coil, which is also perpendicular to the plane of the coil, means A means area vector, and B, the magnetic field, both will be in the same direction. And therefore, theta, that is equal to 0. Now, first we want to calculate the torque. So torque tau, that is NIAB sine theta sine 0, 0. So torque is 0. Now, total force, that is also 0, because if we consider any current element on the circumference of the coil, then exactly for the diametrically opposite current element, the direction of the force, that will be opposite than the first one. And these two forces will be equal in magnitude, opposite in direction, so will cancel each other. So in this way, the net force, that will come to 0. Now, we want to calculate average force on each electron, because when the current is flowing, means that is constituted due to flow of electrons. Electrons are charged particle, and when any charged particle is moving in the magnetic field, the force acts on it. Now, in chapter number 3, we discussed J, that is NEV. And J, that is the current density, that is I upon A. Now, force on the electron when it is moving in the magnetic field B with velocity V. Now here, the velocity and magnetic field both are perpendicular to each other. Therefore, simply we can write magnitude wise the force, that is EVB. Substitute the value of V from this one. So that is I upon NEA, or simply you can say substitute the value of EV directly. So that is I upon NA. Now B is given to you 0.1. Current I, that is given to you 5. Total number of, number density of electrons, or we can say number of electrons per unit volume, that is 10 raised to 29. And area, that is given to you here by pi r square. So substitute the values and you will get answer. Sorry, area is given to you here 10 raised to minus 5 directly. So substitute its value and you will get the answer.